So what did we do yesterday? Divide and multiply rational expressions. So what are we doing today? Adding and subtracting. So in order to add or subtract a fraction, what do you have to have? Common denominator. Okay, just in case there was any confusion, the bottom of the fraction is typically not called a decepticon. That's something completely different. That's what somebody accidentally called it last period, and it was funny. So, numerator, not decepticon. Numerator, denominator. Got it? I think they just had transformers on the brain. Okay? So, what do I do in a case like number 1? So I get 5 over 7. So when you have a common denominator, you add numerators. And what do you do with a denominator? So leave the denominator alone. Is that what you said? So we're not sad about it, right? We're not ignoring it. We're just bringing it along. Okay? I'm right. I'm okay saying leave the denominator alone. Is that if that's what you mean? Because we don't just ignore it and just like write 5, right? We still have to write 5 over 7. Okay? So if we have a problem like this, what do? Oh, no. Let's start over again. What are we doing? Adding and subtracting. So if we get here, what do we do with the numerators? And what do we get? 2 plus x, not 2x. When would we get 2x? If we were multiplying, right? Okay, so I'm glad we went back and started over. So how many of you would write 2 plus x in the numerator, and how many of you would write x plus 2? Which one's more correct? It doesn't really matter, but if you want to write it in the most math way possible, what do we write? X plus 2, because we put our variables first and then our numbers, right? Our constants. On a test or a quiz, would I count it wrong if you wrote 2 plus x? No, I would not. Okay? All right, what about the second example? Can I go ahead and do this? Okay? So I'm still adding. So what do? Oh, I'm combining like terms? Okay, so 2x and 5x, 7x, negative 3 and 7, plus 4. Okay, done. Okay, so far? Am I dumb? Oh, you thought that's what I said. Okay, no. I don't think I am. I am sometimes. I'm a human, right? I make dumb mistakes sometimes. But then again, don't we all? Okay. No, I meant, are we finished? Is that better? Okay. All right, so what about here? What's different? Subtracting. So what do you think our steps might be? Subtract numerators. And keep the denominator. Okay, I'm okay with that too. Do we mean the same thing we wrote up here? Yes, okay. So 8 minus 3. So 5 over 11. You okay with that? So what about here? Here we have to be careful, don't we? Because I'm subtracting. What are people going to forget to subtract? They usually remember the x. They usually forget the 9. Okay? They usually go 2x minus x. Oh, that's x. 11 and 9. Oh, that's 20. Oh, you can, can't you? Can't I distribute that negative to make each term negative? If I do that, what kind of problem is it now? It's an addition problem, isn't it? Okay? Now, isn't that a lot easier? Positive 2 and negative 1, that's x. Positive 11, negative 9, that's 2. Over. So now I can cross out the x's. Can't I? Why? Why can't I do that? Because it's ridiculous. Okay? Now, am I being rude to you when I say that? No. What am I reminding you of? Yesterday, right? I'm reminding you of yesterday. So can we show him real quick because he wasn't here? He wasn't here either. Just remembering. 17 over 19. Can you simplify 17 over 19 by crossing out the ones and by crossing out this bar so that my answer is this? No, that's ridiculous. That's what you're trying to do if you're trying to cross out the x's right here. That's why we say that's ridiculous. It just helps us remember what we're referring to. Okay? Got it? Okay, what about the second example here of subtraction? Should I change the signs again? Do we have to do that? No, just to help. X and negative 9x. Negative 8x. 3 and 7. 10. Ready to go on? Okay with all that? So why is 3 different? Or how is 3 different? There's not a common denominator, okay? So I need you to go with me here for just a second because I know where we're going. So I need to have a little bit of a conversation about this so that we can continue the same vocabulary over here. Are you okay with that? When I get a common denominator, even though it's called a least common denominator, it will be as big as the biggest denominator, if not bigger. I can't tell you how many times when I say to people, what's the common denominator between 8 and 4? 4, they say. Except 8 doesn't divide evenly into 4. 4 divides into 8, but 8 does not divide into 4. See what I'm saying? It's a fraction. We can't do that. We have to find the smallest number that both of them divide into. And for that to be true, it has to be at least as big as the biggest one that's already there. Okay? So what is one possible common denominator for this problem? 16 is one that's possible, correct? What else is there? 8. I want to do this example 2 times. One with 8 and one with 16. Because I need you to see something real quick. Okay? Let's start with 16, because that's what I heard first. Okay? What do we have to multiply 8 by to make it become 16? A 2. So if I multiplied 8 by 2, I also have to multiply the numerator by 2, right? Guys, why do I have to multiply numerator and denominator by 2? Did I change the value of the fraction if I multiply both numerator and denominator by the same thing? I have not, and that's okay, right? So that's why we multiply both numerator and denominator. Hopefully you remember that, because that's not something new that I'm teaching. Okay, so what is 3 times 2? 6. Okay, what do I have to multiply 4 by to make it become 16? 4. So I also have to multiply numerator by 4. So what do I get here? 10 over 16. Well, aren't both of those numbers divisible by 2? What do I get if I divide them both by 2? 5 over 8. Yay, I got an answer. What if I started, though, with a denominator of 8? Because that was the second suggestion I heard, right? What do I have to multiply 8 by to make it become 8? 1. So multiplying the numerator is just the same number, right? Just the 3. What do I have to multiply 4 by to make it become 8? 2. So 2 times 1 is 2. And when I add those, I get 5/8. Oh, look. I got the same answer both times. So which denominator worked? Both of them. Which one was the least common denominator? The 8, right? Notice here I had to, once I got an answer, I had to simplify it, right? I had to do an extra step. I still got the same answer, though. That's what I want you to see. Yes, we want to choose the least common denominator because that will cause us less work, okay? But if you choose a denominator that's not the least common denominator, you still can get the answer if you simplify. So every denominator works then? I could choose 10. That would be a mess, wouldn't it? Okay, if I was careful, I might still be able to get the answer, but it would be a mess. A mess. Everybody okay? So what were my steps? Find a common denominator. The least common denominator if I can, right? That would be preferable. And then add or subtract, whichever one it asks for. Okay? I don't feel like I have to write the same rules up here because I already wrote them once, right? So, here we are. Okay? I want to find a common denominator, the least common denominator if I can. So I'm going to say to myself, self, is there a factor that they both contain? An x, right? They both have an x. So that's going to be part of my common denominator. Is there a factor that one of them has that the other one does not? A 3. That also has to be part of my common denominator. Is there a factor that the second one has that the first one does not? No. So what's my common denominator? 3. Now, what I want you to understand is the way I talk you through this is the way that I found that it's simplest to explain a common denominator. It's not how I think when I'm trying to find a common denominator. Okay? Because I can typically factor pretty fast in my head. You guys are getting there. Okay? This is just the easiest way to explain it. If you look in a textbook or if you look online, they probably use some different words to get a common denominator. Okay? Like we did here. We said, what's the smallest number that they both divide into? Well, could you think about that here? What's the smallest number that they both divide into? Yes, but it's a little more confusing when there's variables involved. Does that make sense? So, this is how we're going to talk about it. Are you okay with that? So, what does this one need compared to this one? It doesn't need anything, does it? It has the same exact factors. So, what do I do with the numerator? So, leave it, right? What is this one missing? What factor is it missing, right? It has to be multiplied by 3. So if I multiply it by 3, I have to multiply numerator by 3. Okay? Well, I'm going to do a little bit of work right here to save myself in a minute. 3x plus 3. Are you okay with that? Some of you can do that all in one step. And if you can do it all in one step, bring it all over here and say 3x plus 3. And that's fine with me. Okay? Now I have a common denominator, so add. 5 plus 3x plus 3. 3x plus 8. And now I just simplify the 3x's. So forceful, Grace. You're getting so forceful about that. No. No, I'm proud of you. I'm proud that you know. Because what would that be if I was trying to cross that out? Ridiculous, right? That would be ridiculous. Can't do that. So this is the answer. What about this one? What do you think I might need to do first? I might need a factor first, huh? Okay. Can I factor this? Both terms are divisible by, so I have x plus 2. Oh, that makes it so much nicer, doesn't it? What factor do they have in common? X plus 2. They both have an x plus 2. Why don't I have to write x plus 2 twice in my denominator? Because there's one of each, right? Why don't I have to write x plus 2 twice? If they both have it, then we only need it once, don't they? Don't we? If they both have it, the 8 and the 4, they both have factors of 4, right? 8 is like 2 times 4. I didn't have to say 4 times 4 times 2 to get my common denominator, right? If they share a factor of 4, I know that has to be there, but then this one also has another factor of 2, and that had to be there as well. Okay? So they both share an x plus 2, so that's part of the denominator. What factor does one have that the other one doesn't? A 2. So they both need a 2 as well. Is there any other factors that one has that the other one doesn't? No? Okay, so what does this one need compared to what it had? Well, it's exactly the same, so what do we do with the numerator? Nothing. We just recopy it. Okay? What does this one need to become this one? It needs a factor of 2, right? So I multiply both numerator and denominator by a factor of 2. And I get 18. What is x plus 1 minus 18? Minus 17. Good. And that is the answer. Yeah. Okay so far? Are you lying? No? You okay? All right. Number 4. Example number 4. What is the common denominator? How did you get that number? Remembering how to do it from 4th grade, okay? So when in doubt, what do you do to find a common denominator? Multiply them together, okay? So if this is 35 and this is 35, what did this one need? What factor did it need to become this? A 5, so we multiply numerator by 5. What factor did this need to make it become 35? 7, so numerator and denominator both multiplied by 7. So this numerator is 5 times 3. This numerator is 7 times 2. So that my final answer is 29 over 35. Excellent. Okay? So look here. Is there a factor that they share? No. So what factors the first one have that the second one doesn't? An x. What factor does the second one have that the first one doesn't? 3. So guess what the common denominator is? 3x. And like we talked about over here, when in doubt, multiply them together. 3x. So what factor does the first one need in order to become the common denominator of 3x? A 3. So if I multiply that one by 3, denominator, I multiply numerator by 3 and I get 15. What factor does 3 need to make it become 3x? An x. So if I multiply numerator, then I also multiply denominator. So 2x squared. So what's my answer? Careful. Why is it negative 2x squared? Because I'm subtracting. Yeah, exactly. Now, would it be okay to write 15 minus 2x squared? Would it be okay to write 2x squared minus 15? No. You have to be careful. Okay? We forgot to write our steps. What are our steps? Find a common denominator. Then add or subtract. Excellent. What about this one? Is there any factors that they share? Can I tell you what they said earlier? They both have an x. Is that a true statement? Is the x a factor? No, it's a part of a number. It's inside being added or subtracted to something. So I'm glad that you recognize that they both have an x, but that doesn't matter right now, does it? Okay, so what is my common denominator? Yeah, when in doubt, multiply them together. Okay, x plus 3, 2x minus 1. So what factor does the first fraction need to become the common denominator? 2x minus 1, so I multiply that by the denominator and the numerator. So what does it become over here? What does the numerator become for the first fraction? 8x minus 4. Could I right here write 8 times 2x minus 1? I could, right? But then I would have to simplify it in order to go on to the next step, right? So I'm just kind of doing 2 steps in one, aren't I? Okay. What does this denominator need to make it become the common denominator? X plus 3. So if I multiply it by x plus 3, I have to multiply the numerator by x plus 3. So what is its new numerator? 7x plus 21. Now I have a common denominator. I keep my common denominator. x plus 3 over 2x minus 1, and I add my numerators. 8x plus 7x, negative 4 plus 21, plus 17. How are you feeling? Okay. Because here's the next example. You want me to do 5 or 6? Or 7? 6? Okay, let's do 6. What should I do first? If I'm trying to find a common denominator, which I'm trying to do, I've got to factor the denominators that are there to see what factors are there, right? So what multiplies to be 12 and adds to be 7? 4 and 3. Can I factor this one? A lot of people see it and see 2 terms and think, oh, I can't factor it. But what you notice is, absolutely, they're both divisible by 2. So if I factor out a 2, that makes it really nice. Because what I notice then is that they both have x plus 4, so that has to be part of the denominator. Does the first fraction have a factor that the second one doesn't? Does the first denominator have a factor? What is it? X plus 3, so that has to be part of the common denominator. Does the second denominator have a factor that the first one doesn't? A 2, that also has to be part of the common denominator. Have all the factors been accounted for? 2 times x plus 4 times x plus 3. Now I can get around to converting to the common denominator, right? What is this first one missing? What factor? A 2, so I have to multiply numerator and denominator by 2. What's left after I multiply by 2? 2x plus 12. Excellent. And what is the second denominator missing? X plus 3. Do you see what I'm saying when I'm saying what is it missing? What factor is it missing? I should be more clear with my vocabulary. I apologize. And here, what do I get? 5x plus 15. So when I go to write my answer, 2 times x plus 4 is my denominator times x plus 3. Now I need to distribute the negative so that I can subtract a little easier. Okay? So I have 2x plus negative 5x. Negative 3x. And I have 12 plus negative 15. Do I need to factor my numerator? Do you notice it has a common factor between the two of them? Do I need to factor my numerator? If I did, it would look like this. When might that be a useful thing to do? What if I had a factor in my denominator that was x plus 1? Couldn't they cancel then? So, do I have to this time? No, because there's not a common factor in numerator and denominator. It's nice to think about just in case there is, but this is a perfectly fine answer right here. Okay? Any questions? Would you please circle the following questions on the next page? Number 1, number 3, number 4, number 6, and number 8. 1, 3, 4, 6, and 8. Okay? Those are the problems I want you to do. Do you want me to do 5 or 7 since we still have a couple minutes? Which one? 7? Okay, what should we do first? Factor. Multiplies to be 8 and adds to be 6. 4 and 2. Multiplies to be negative 6 and adds to be negative 1. Very good. So what do you think my common denominator is going to be? For sure x plus 2, because they both have it. And then what's left? An x plus 4 and an x minus 3. Don't they both have to be part of the denominator? X plus 4 and x minus 3. So what does the first denominator need to be multiplied by to make it become the common denominator? X minus 3, so that this one needs to be multiplied by x minus 3. So x squared minus 3x plus 3x minus 9. Oh, this is nice. Oh, we knew it was x squared minus 9, because that would be like the difference of squares, right? Okay. What does this one need? And he's in x plus 4, right? X plus 4, x plus 4. So what does it become? 9x plus 36. Now I have a common denominator of x plus 2, x plus 4, and x minus 3, so I can combine my numerator. X squared plus 9x plus 27, right? Negative 9 and positive 36. Oh man, that looks like a trinomial. Should I think about trying to factor that just to make sure? Is there anything that multiplies to be 27 and adds to be 9? Yeah, not that I can think of either. So is it okay for me to leave it like this? If I could factor it, do I have to? No, only if there's something it can cancel out in the denominator, right? To simplify in the denominator. Okay, just something to think about. You have the 5 for homework. Any questions?